Okay, I think we are live. Nope, I didn't have audio. Interesting. So this is, apologize, I'm going to start all over. Hi there, hope you're doing well. Today is April 17th, Wednesday, 9:52, and starting a little bit later compared to normal. And I'm looking over at my streaming software, and I don't think I set up audio for that particular camera view, which is embarrassing. I apologize. Today, we are going to take a look at Cyan. Cyan is a testing library in the same spirit as something like Enzyme for React, allowing you to write really quick unit or integration tests or whatever within the realm of JS DOM. This virtual simulated DOM browser environment that lives within Node. And the advantage of having something run within JS DOM is that it is lightning quick because you don't need to spin up a browser like you would in something like Cypress, Puppeteer, Selenium, or any of that kind of stuff. Um, yeah, it's good stuff, but the main difference is between something like Cyan and Enzyme is Cyan you write your tests and you assert them against what React renders into the browser or the DOM. Whereas in Enzyme, you would write your tests based on how your React components interact with each other, focusing more so on the React components themselves, how the props are being passed, how the state changes, and so on. So you're kind of testing integration details versus what the results of those integration details are. In this kind of testing the result philosophy, I was very heavily inspired by the stuff that Kenzie Dotz did with React Testing Library and also DOM Testing Library. Fun fact, Cyan actually uses DOM Testing Library internally to simulate DOM events like clicks, hovers, not hover, oh yeah, hovers, mouse enter, and all that kind of stuff, which is fun. So the goal of Cyan is to give you a Cypress-like API in order for you to write your tests. We've been using Cypress a lot more with our stuff. It's a great library, very, very robust. The tooling is fantastic, being able to see the Cypress run within their Electron application, having videos recorded and all that kind of stuff. That fancy stuff isn't supported in Cyan. Cyan is just going to be running inside a JS DOM, and that's all you get. You don't get video recording or any of that kind of stuff, but you do get a lovely API that's very similar to Cypress, which is very similar to jQuery, which is a nice kind of nod to the past. So here we have a very quick example where we have a modal that has a trigger and has some content inside. So for this particular modal, which is based on the modal from HSDS React, the content doesn't render until the modal is open. The modal uses an internal portaling mechanism and so on. Don't need to worry about that. Me as the user or the person who is viewing the DOM or the browser, I just don't need to see a modal right now. There should not be anything on the screen. So in this particular test, I'm going to find the button via this get method on Sci. And again, this is very, very similar to Cypress, and this was intentional. A lot of the Cypress APIs have been brought over and kind of emulated here with some additional ones added in. So here I'm going to get my modal. I'm going to check to see if it has a class of isOpen. It should be true because now the modal is open. And I should see that the content is now rendered. However, once I click the close button, this get by size is another getter mechanism that basically it's a short form of get that means that you don't have to write something like sci get data sci equals close button. Whoops. Yeah, it's just a short form of this, because data sci is the convention that Cypress has, at least the way that we use it. So having this built in to the library as sort of like a first class method is great. So now I'm clicking the close button, and now the modal should be closed. There's no more is open class, and the content should no longer exist in the browser. Cool, and that is our test. So for me, after working within the realm of enzyme, doing a lot of DOM-related tests inside of JS DOM with enzyme, this is a godsend because being able to test a feature-rich component like a modal that does so many things to do with timing, DOM injection stuff, all this stuff, to be able to do it within to test the entire life cycle of the modal, of opening and closing it, to be able to do that within 6 lines is amazing. Because if I pull up a modal test, I can probably do it right now. Inside of HSDS React, if I open this, I don't even know, modal test here. So I have to fake some timers. I have to do some before each clearing of the document body inner HTML because that's where a modal actually gets injected into the DOM via a portal. I have to write this simulate key press helper so that I can trigger an escape key inside of the virtual environment. There's a lot of things I got to do in order to like, I don't know, make this work. The routing, oh yeah, if there's routing concerns, I have to create a router, a memory router, and then do some things. I have to do a lot of things in order to get something working. Whereas inside of Cyan, not much. There is support for Redux and also React Router out of the box. It is mounted or rendered with these things for you. So there is a provider coming from Redux and also a router coming from React Router. Memory router, yeah, that's correct. So router is something that I'm going to be working on today in this live coding session. Hopefully it goes well. And we'll see how this goes. So I'm not going to get into the little details of Cyan. This was just an introduction to the library and hopefully helping you folks see the value of it. At the very least, I think it's valuable for someone like me working in the UI layer, that is HSDS React, being able to write very simple tests. Yesterday, I did a kind of like, let's see what happens test by rendering an entire React application with mock APIs built in, promises from those APIs, a router, a React Redux, everything. Literally an entire application within Cyan. And it was fine. It was able to render. I was able to test the initial loading state, what happens when the loading state resolves. Similar to this, it was just a couple of lines in order to get that working, and I was able to render the entire application. And that's fantastic. And it was able to do it within 50 or 60 milliseconds on this very powerful MacBook Pro. And if you're using a not so powerful one or an older model, it might take a little bit longer, but it'll be within the realm of milliseconds versus seconds, because seconds is what you get from Cypress, which is fine, it's understandable. You're rendering inside the browser, but here we're doing JS DOM magic stuff. Cool. So with that out of the way, I am going to start writing some tests to kind of see how I can improve the routing experience for Cyan. So one thing from my test yesterday that I discovered was there's 2 things. By default, Cyan has this guy built in, use fake timers. And this is just a convenient feature so that anytime the user performs or you simulate an action, be it a click, a hover, or any of that kind of stuff, it increments timeouts for you. So you don't have to do something like this. Let me pull up a test. Mm, nope, that's not a test. Action. Here. Do I have a hover? Yes. So here we have a key down event for the key press of enter. And man, just telling you now, this is so much nicer compared to Enzyme. This is basically a copy of Cypress's API because in Enzyme you have to, assuming you have the node, you have to do something like um, node simulate. I forget even how you do this anymore. Simulate event? I could be very wrong, but you simulate the event, you pass in the event name, key down, and then you pass in the event code like this. Key code, what is enter? 13? I don't know. I may be very wrong. The only one I remember is escape because I had to work with that recently. So this is the difference between something like Enzyme and something like Cyan. Oh, wait, no. And also with Enzyme, you got to do this. Just run only pending timers or all pending timers, whichever one you want. You got to write these two bits of code in order to simulate what you'd get from Cyan out of the box with this key press. So with that said, by default, timers are fired and incremented for you for every single action you perform. But there is a problem when I integrated this into an environment that by default does not use mock timers. So my thinking here is perhaps I shouldn't default to having mock timers turned on. Just because I want the integration of Cyan to whatever application or module to be seamless. So, ideas. We could have a global, say, configuration.js file here that has specific methods that allows you to do things like use fake timers for that specific test run for that specific file. And the internals of Cyan, like these events, will do a check to see if it should automatically fire those time incrementer thingies for you, that the run all timers kind of thing. So I'm just going to write this. I'm going to see what happens. So I'm going to do npm run dev, which fires up just inside of watch mode. I'm going to run all my tests to make sure I didn't break things. Oh yes, Cyan has 100% test coverage, by the way, which is really nice because now I don't need to worry back about backfilling any of this kind of stuff. Because typically when I code things, I don't write tests along the way, just because I'm very much in exploratory mode, just to see how does this thing work. That's just how my brain works. It's difficult for me sometimes to do TDD, especially when I don't know what the heck I'm building. Cyan came from kind of like a hack idea, a project that I had. I mean, I've always kind of wanted to build this, but the urge to build it came over a weekend and just kind of threw something together and it kind of worked and it's great. So now we have Cyan. Cool. Configuration. I've been using this pattern a lot. This was something that Nicholas and I strategized on, and that is storing variables as singletons within files. For example, this is a good one, store, like this. And then you have getters and setters that can either get or update those variables. And those variables are then used globally throughout your application module or implementation or whatever it is. And this is really nice because now you can access and manipulate those things so simply by doing just like an import of that setter method and just running with it. So it's great. By the way, I don't have live chat or anything open right now, so if anyone is chatting, I apologize. Most likely not, because typically no one watches these live streams until after the fact. Just cool with me. Configuration is an empty object. Const initial configuration. Kind of don't like these names, but it's fine. Okay, what is the initial configuration? The initial configuration is Use fake timers is false. Okay. Um, thinking. Um, const update configuration. We have the next configuration. I kind of want to use the word state because it feels like a very React kind of set statey kind of thing. Uh, sure. Initial state. Yeah, let's just run with it. Initial configuration state. Cyan configuration state. Cool. So here we have set config state. This feels better for me. So in the standard set state API, we have a set state and also, or sorry, you pass in a state and then you have a callback. This is built inside of React. You typically you do set state and then you pass in the next state that you want. Hello. So if you had, say, a set state there, and then you had something like a console log this state, there is no guarantee that this state, whoops, will be this. Most likely it will be, but there's no guarantee. So in order for you to guarantee that, there's a callback mechanism built inside a set state that allows you to do that. And you would get the new state here, and then you can do whatever it is you want with the new state. Cool. So that is how React set state works, and we're going to replicate that same API because it just feels intuitive to me. I already built something like this inside of here, so I'm just going to copy this. Set config state. We have a next state, we have a callback and variant. Yeah, so uh, sure, I'll stick with the same techniques here. So, gonna copy all this, add it inside of here. Cool, cool. State is this. So state equals, I need a next state here. Deep merge state is, So first I need, so get deep merge it with the next state, and now I have my state. And my next state is, I am going to set it via this. And now I can, that's it. Cool. So I can now get and set my state like so. And it can be done globally, and it's fine. So this invariant stuff, sorry, this is just phone ringing, and it's not mine, but it's buzzing my table because I'm at a co-working space. So, excuse me a second. No idea what's going on. Um, so I found this to be really useful in building a library like a test utility library or a test runner or anything like that, because when you're testing, you don't have the luxury of a DOM to be able to see that things are going on, or things that are going wrong. The only thing you have is whatever you see inside of your terminal. So you have to try to make it as dev friendly as possible so that folks aren't hunting and pecking and figuring out what the heck is going on. So having things like invariant or warning throw errors or console warn things based on certain situations is really helpful. And since this library is designed to be used inside of Node, um, having these things don't bloat your bundled code because inside your tests are going to be shipped with your code anyway, so this is fine. And these libraries are super tiny. This is actually my first time using things like invariant, and I've seen it all over the place, like React Router and so on. Um, but yeah, they are like 500 bytes. Amazing pieces of code. I love it when modules are super tiny. I'm gonna move my camera a bit. Cool. All right, let's see. So now I have the ability to set and configure my state. We will now create a file called timers. And we have a function called use fake timers. So you would use this. So my idea is you would use this, use like use fake timers at the top of your file instead of just use fake timers. Because our special version does eventually fire just use fake timers, but it syncs up with the rest of the system in order to push along those fake timers whenever the user performs an action. I want to bind that together so that there's less things for the tester, by tester I mean the person writing these tests using Cyan, to have to use when doing this stuff. Okay, so now I need to tap into that configuration state thing that I was talking about. So import set config state from configuration. Also, side note, I'm writing everything inside with JavaScript instead of TypeScript. Reasons is I find that when I'm exploring ideas, it's very difficult to do it with TypeScript just because it complains all over the place. And it's a distraction for me to like figure out what it is I want to build. Because the set config state, of course, it has to have, or rather, this initial state, it has to have a shape of some kind, and then I got to write the types for it, and so on. So this is a typical flow you have with TypeScript, which is fine. I think, especially in an application, something like that is really important. And also within a library as well. But right now, I'm kind of exploring. Once I feel like I have a good foundation for the library, I can either write types manually, which I might do, I have reasons, or convert files to TypeScript. So the reason why I might write types manually is because I'm exploring the ability to have inline docs with my code here, like this. So these docs eventually render to this using documentation.js. It's fine. There are some things I kind of have issues with, at least from the CLI out of the box. Probably need to adjust some things with Node commands, but it's fine. So anyway, sidetracking. Use fake timers. What we're going to do is we're going to set config state of use fake timers to true. This is a synchronous call, so it's fine. Ooh, excuse me. And now once that is done, I will just use fake timers. That's all of this is. It sets an internal config, and it does a use fake timers. So here I am going to tap in to my commands like, where is it? I need to tap into some of these guys. Action? Yeah. Things that increment the timer forward. Run all timers. Okay. You so I'm just so the reason why I kind of hesitated or paused right there is because I kind of wanted to use the verbiage of use, but since the release of hooks in, I believe, 16.8.4 of React, anything prefixed with the word use is now associated with the concept of hooks. So use state, use context, use reducer, all those guys. And this is so not React hooked, so can't do that. Instead, I am going to use the same method name as what you would get from Jest. And I feel like that relationship between naming is stronger. So this is one of those things where naming is hyper important to get right. Not only should I don't know, be very descriptive, but like the user or the tester that's using this library should be able to intuit these methods without even having to consolidate docs or even having IntelliSense or anything built into their IDE to figure that out. They should just be able to intuit this stuff. So anytime you're writing any bits of code, especially if you're working on a team, name things and put things in a way that your fellow team member or someone else can intuit how this thing will kind of work. That is good design. Um, so run all timers. What is it going to do? It is going to get config state. I'm going to have some selectors in here. Why not? Export const if should use fake timers is, what is it? It's a function that gets the config state, use fake timers, and does a check to see if it resolves to true. So instead of getting config state, I'm just going to use this selector to do so. So if should use fake timers, then just run all timers. So there is a run all timers. There is also a run only pending timers, like so. Great. So now I have my wrapped and protected methods for running timers and setting fake timers. So what am I going to do? I am now going to find all instances where I'm running fake timers, and I'm going to use my special timers functions instead. So here, import, was it use fake? Nope, no. Run all timers from .. timers? Yeah. So I'm going to find all cases of this there and there. Great. So now, I guess I don't know if the test should pass or not. They still pass. Okay, cool. And I think we'll see what happens. We'll see what happens. Cool. So I need another one here. Import, run all timers from .. timers. By the way, I did not forget about the live stream / screencast of going deep into dropdowns within HSD. That's the part 2 of it. I just wanted to talk about this one today, and hopefully for the next one I'll talk about dropdowns. Okay, now a test failed. Right. I expected this because we see here we have a click. We have a click function that fires when we click on the button. And now, because the timer isn't incremented for us anymore, the modal can't like resolve itself in the render process in order to assert against whether or not the content should still exist. So to prove this, if I go into examples and I go into, what is this? This is a modal. Which one is it? Line 21. So if I do something like just run all timers here, it should pass because it's incrementing the timer for me. But now that by default the timers aren't done for me, this will happen. Great. So now we have a stateful system that the user can interact with to say whether or not they want to use fake timers, VSI or Cyan. And if you do, the events built into Cyan will automatically increment the timers for you, so you don't need to fiddle with that stuff. Great, so now all this is working. I'm going to check the other places that still just use fake, or sorry, run all timers and replace it with the one that I just created. Timers. Run all timers from here, and then I'm just going to replace it here. Where else am I using it? Timers, that's fine. Key event, here we go. Import run all timers from dot dot slash run no timers. Okay. One more. Okay, this is fine. So now we've taken care of run all timers. That's great. Run only pending. I don't think I've used any one of these. Fine. Cool. Great. Use fake timers, run. Okay, so now what I want to do is I want to bind these particular functions to the main Cyan object, essentially, that you get when you import Cyan from Cyan. So it is import use fake timers, use run only, run all pending timers from dot timers. Okay, so now I have these guys. I will just add them to Cyan, like so. Great. And now I have the ability to do this. Here's one way we can clean it up as timer functions. And now that's an object. I will then spread the object like so. Great. That's even cleaner because now I don't need to, I can add more and it'll be fine. Yeah, so now my tests are failing because I don't have, so I need to remove this guy now. So, but it'll still work, but I need it to be reset. So here's a problem. I want my configuration for using fake timers and stuff to be reset after every single test run. That's the opinion I have. I don't want it to be like if I had 10 files and then I did a use fake timer here from Cyan, it should not affect any one of these guys, whether they run sequentially or in parallel. So in order for me to do that, I cannot add this in here. Not only can I not add it in there, I have to go back to my timers mechanism and say at here inside a config state, after all, I'm going to create a new one, const reset fake timers. Reset use fake timers. What does that mean? That means that I will set config state to have use fake timers as false. And I will do this for after all run reset fake timers. Great. Cool. So I just to see if this after all thing is working when I fire a set config state inside of here. I kind of don't like this. Maybe this. abstracting it into a single method like that is probably better. Okay, cool. So now I'm going to console log happy, and hopefully I should see I don't see logs for happy. That is probably because I am not using fake timers anywhere. Right. So let's jump to the modal test. So now I have my psi. I'm going to do psi use fake timers. And theory is that modal will then pass. It does. And then after modal passes, we see happy because now happy is being run via this mechanism here, like so. So this reset use timers, I kind of don't like this function being here because this configuration, this is configuration stuff. This is not a selector of any kind. This is a function or a method that's specific to timers. So I might just cut that out, add it here, remove this happy thing. That's fine. And inside of that should not be run there. It should be run inside of setup tests. So inside of setup tests, I will reset use fake timers from from timers. And this is my kind of global area with jest based hooks, lifecycle hooks. So yeah, this is the right place to put it. Cool. So I'm going to reset the store here, and I'm going to use fake timers here, and this is where things kind of clean themselves up. So now inside of my drop-down test, I am going to psi use fake timers, and without touching my tests, everything should pass in theory, which it does, great. And any action I perform, like clicking like that, it'll increment the timers for me. And the timers then get reset after every single run. So I guess that's it. Now I have what did we do? We adjusted the API for psi to default to not using fake timers to make it smooth and seamless to integrate that into any existing test suite for your application, your module, or your whatever. But we want to preserve that convenience built into certain user-driven events like clicking and so on that increment the timers for you. So in order for us to facilitate this, we're creating essentially a global config of some kind, some state that stores a Boolean to whether or not we should use fake timers, and we provided setters and getters for that global store that now exists as a singleton within configuration.js. And we've crafted a couple of timer-based functions like use fake timer, run only pending timer, and so on that you would get from Jest that run the native Jest methods under the hood. However, it does a check and also it taps into our configuration store for timers to see whether or not they should actually fire. Once we have that, we refactored our actions to use these particular methods instead of the out-of-the-box Jest ones. That way, they are now integrated into our configuration timer system. And the last piece is to hook all that stuff up into the Jest lifecycle hooks for your tests. That being after all. So after all my tests have been run for this particular file, restore the use fake timers thing back to the original state, which is false by default. And we've also removed there was a before all here. that did just use fake timers because now we no longer want to do this as the default behavior. And with that, without touching our tests, with the exception of declaring the fact that we do want to use fake timers for modal test file, and if you do, actions like clicks and so on increment timers for you um, automatically. That way you don't have to do just run all pending timers. Cool. Great. And I think that that's I'm pretty sure my test coverage went down just because I added additional commands and things. We'll see. Yeah, went down a bit. So I need to write some tests for timers. But with that, we have handy dandy, a much better support for seamless integration with Cyan. So what I'm going to do now is I'm going to write some tests for timers and also configuration to bring it back to 100, create a release for Cyan, and that'll be that. Thank you so much for tuning in. Hopefully you found this useful. I've been Q, you've been wonderful, and I hope you have a great day. Take it easy. Bye.